The curved line PQR is the velocity time graph for the car starting from rest. So what is the average acceleration? We have to find average acceleration. So average acceleration over the first 5 seconds. You can see average acceleration is the total change in velocity over total time. And the gradient of this line will give us the average acceleration. Gradient of line PQ. So the gradient of straight line PQ will give us average acceleration. And why not, what will be the gradient of tangent will give us? Gradient of tangent will give us the acceleration at 5 seconds. Okay. So area of the velocity time graph will give us displacement. Okay. So if we are interested to find acceleration, then it must be linked with the gradient, and the gradient of tangent gives us the acceleration at that particular time, and then the gradient of this line that starts from the origin and goes to this will give us total change, that is total change in velocity till that time over total time, which is 5. So the gradient of straight line PQ, this is our right answer. Question 14. The graph shows how the speed V of the sprinter changes with time t during 100-meter race. So what is the best estimate of the maximum acceleration? So speed time graph, if something moves in the same direction, then the sign of speed doesn't changes, and the speed and velocity is the same thing. So the gradient of this graph will gives us acceleration, and we have to find maximum acceleration. We have to look for the part of the graph with the maximum gradient. Okay, first of all. So you can see in this part from here till here, we have the maximum steepness. Steepness over here is some less value, then steepness increases, and it has some constant value, then steepness over here decreases. So you can see steepness over here has decreased, then steepness over here is 0, and steepness is negative. So we have to find the area of the part highlighted with blue color. So that is how to find the area of this part. Area will be rise over run. So over here we have 8, over here we have something like 1. So 8 minus 1 is 7. What about this base length? You can see it is almost 2. Okay, so 7 over 2 will gives us 3.5. 3.5, so around 3 is the right answer. Question 15. The diagram shows a velocity time graph for a mass moving up and down on the end of spring. Which point represents the velocity of the mass when at the lowest point of the motion? Velocity at the lowest point of the motion. Okay, so as the object is attached with the spring, when you will pull it and release it from here, that is the lowest point, the velocity over here will be 0. Then as it moves in the upward direction, velocity increases, and because the spring has maximum extension, over here the extension becomes 0, so velocity is the maximum value. Then as it moves in the upward direction, it slows down. Okay, so at the bottom or at the top, the speed is 0. Okay, so lowest point can be either B or D. So how to pick, how to decide which one is the correct option? So this shows the up direction. So at t equal to 0, this means the object is at the bottom. Okay, it moves in the upward direction and the velocity of the object increases, it becomes maximum. That shows this point. Okay, then velocity decreases, and it is 0 at the top. That is the top point. Then as it moves in the downward direction, the sign of velocity changes. So velocity becomes negative. It is maximum at the center, and again it becomes 0. So D shows the point when the spring is at the bottom. So D shows a point when the spring is at the bottom, okay, at the lowest point. A ball is released from rest over a horizontal surface and bounces several times. The graph shows how far this ball, a quantity varies with time. So on the y-axis, you have some quantity y, on the horizontal axis, you have time, and we are given this graph, that is velocity time graph, any graph, we have to find what is y. So what is the quantity y? So the ball is released over the horizontal surface, and as it moves down and has maximum bounces, multiple bounces, you know that if air resistance, if we ignore air resistance, then the acceleration of the ball should be constant. Okay, and acceleration should be always in the downward direction. So kinetic energy of the ball should be 0 at the start, and it should be again 0 after first bounce, then it should be 0 after second bounce. So the kinetic energy should touch to the 0 value at multiple times, but over here you can see it is not becoming 0 after t equal to 0. So that's why it can't be a kinetic energy graph. And the velocity over here, you can see the velocity will increase, and become maximum. And then as object moves in vertical upward direction, then the sign of velocity should change. And over here, and the velocity time graph should be straight line portions if we ignore air resistance. Okay. So that's why D can't be the right answer. What about acceleration? Acceleration should not change. Acceleration should be constant. So that's why A is also the not option, and B is the right answer. We can see YB at t equal to 0, displacement over here is 0. As ball moves down, displacement increases, it becomes maximum. You can see. Then as it moves up, the displacement, it is moving on the same line. So displacement from point O will decrease, and after first bounce, it will not reach to the maximum height. So displacement will have some least value. So after reaching the top after first bounce, it will go down, and displacement will again increase, and it becomes maximum, and so on. So that's why it is displacement time graph, and you can see the displacement time graph is a curved line. So you can conclude the velocity of the object is changing. The sphere is released and falls. Its initial acceleration reduces until it eventually begins to travel at constant terminal velocity. So terminal velocity mean the velocity will become constant, and this is displacement time graph. So the gradient of displacement time graph gives us velocity, and gradient should become constant. Okay. So over here in option A, you can see initially a ball is released. So ball is released and it falls. So the displacement time graph gradient will give us velocity, and the gradient at the start should be 0. Okay. It has some non-zero value gradient, non-zero value, and in option B and D we have almost a 0 gradient. Okay. Over here, gradient increases, and after that becomes constant. So if the gradient is constant, that means the velocity has become constant in this part, and over here in B, the gradient is increasing. So gradient of the displacement time graph should increase and it should become constant. So what is the right answer? The right answer is D. Let's do question number 18. That is very interesting question. The graph of velocity against time of an object moving in a straight line is shown. So velocity increases at constant rate, then it becomes constant, then it decreases. Okay. So we have to find the corresponding displacement time graph. You know, gradient of displacement time graph is velocity. Okay. So if the velocity is increasing, then we can conclude that the gradient of velocity displacement time graph should increase. Over here, the gradient is 0. Over here, in the first part, gradient is constant, then constant, then constant. So that's why B and D are incorrect. The gradient is increasing in, over here you can see gradient is increasing, then gradient becomes constant. Then gradient becomes negative in first part. You can see the gradient has become negative. But the velocity is positive throughout. So gradient can't be negative. Okay. So what is happening? That's why A is incorrect. Why C is correct? You can see from this part to that part, gradient is increasing. Then for this interval, gradient is constant, then gradient decreases. So that's why C is the correct option for this question. Question number 19. This is the latest question that came in May, June 2023, variant 1-2. A rock is launched vertically upwards from the surface of Earth, and an identical rock is launched vertically upwards from the surface of Mars. Each rock is launched with an initial velocity of 12 meters per second. Each rock then reaches its maximum height above the surface before turning back down to the surface. Okay. The velocity time graph for each rock is shown. You can see on Earth, its initial velocity is this 12, then it decreases at constant rate, and it reaches at the top on Earth. Okay. So the object is launched in the upward direction, it moves up, it reaches to the maximum height. Its velocity over here is 0. That is at the top position. Then it comes down. The direction, the sign of velocity becomes negative. So it is coming down. Same is true for Mars. The initial velocity is same. It reaches to the top position at this time, then it is going down. So what do we have to find? What is the difference in the maximum height of two rocks? So height is calculated, displacement is calculated from velocity time graph by area. So height on the Earth, the height that the ball reaches on Earth to its maximum height is calculated by this area, and the height on the Mars is calculated by this area. So they are simple two right angle triangles. So you should find the area of these right angle triangles 1 by 2. Let me calculate the height on the Mars. The base is that is, you can see on the horizontal axis, the 10 small divisions are equal to 10 small divisions equal to 2. So 1 is equal to 0.2. So that is 1, 2, 3, 4, 5. That is 3, and it is 3.2. So on the horizontal axis, it is 3.2, and on the vertical axis, it is 12. That is 12. So that is the height reached on the Mars, minus for Earth. That is the base is 1, 2, 3, 4, 5, 6. That is 1.2 times 12. If you will find the difference of these two, you will get the correct answer as A. Okay. What about question number 20? The graph shows how velocity v varies with time t for a buggy jumper. At which point is the buggy jumper momentarily at rest, and at which point does it have zero acceleration? So we have to find 2 points, one for rest and another for zero acceleration. You know, the gradient of velocity time graph gives us acceleration, and gradient is zero at turning point. Over here, gradient is maximum, it decreases to zero. So at point Q, gradient is zero. So acceleration at point Q is zero. So for zero acceleration mean it is at Q. And at which point it is at rest? Very straightforward question. The velocity should be zero. So velocity is zero at the start and at the R. So at R, the velocity is zero. Okay. And at Q, the acceleration is zero. So that's why C is the correct answer. Most of the students confuse themselves by taking point R as at of zero acceleration. At R, velocity is zero, but acceleration is not zero. Gradient over here is not zero. It has some gradient over here. That's why acceleration at R has some non-zero value. The velocity of an electric car changes as shown. Velocity is in now. Be careful about this. Kilometer per hour. The time is in second. So what is the acceleration of the car? Acceleration is the gradient of velocity time graph. So you have to find the gradient of this line. That is rise over run. But be careful about converting this kilometer per hour into meter per second. Okay. Most of the students just take 100. You can say 10. That is 110. Okay. No, 105. 105. One small square on the vertical axis is equal to 5. These are 10 and they are representing 50. So 1 is equal to 5. So 105 kilometer divided by 4. Most of the students do this. But please remember, you have to convert this into meter per second from the kilometer per hour. So 105 kilometer is 1000 meter over 3600 second. That is rise divided by run is 4. So you will get the correct answer. 22, the graph shows. So your answer in this part 21 should be, I don't have any calculator, so #21. So the answer should be D. That is the correct answer. You can verify your answer. Even if you stuck somewhere and you don't have answer, this is October number 2012 variant 11. The last number is variant and this number is year, and that is the question number 8 of that year. The graph shows how the acceleration of an object moving in a straight line varies with time. The object starts from rest. Which graph shows the variation with time to the velocity of an object over the same time interval? So we are given acceleration time graph. So we have to find the velocity time graph. Velocity, the gradient of velocity time graph is acceleration time graph. So if acceleration is increasing till that point, that shows the gradient should increase. The gradient should increase. So over here, if you check A, the gradient is increasing till that point. You can see the gradient is increasing. Then after this point, the acceleration is decreasing and it is positive. So the gradient should decrease. That's why A is the correct option. Okay. The value of acceleration is throughout positive. That means the velocity time graph can't be this thing. Over here, acceleration is negative. Negative. Okay. And again, over here, acceleration is negative. Till that point, acceleration is negative. And D, acceleration is positive, but it is always increasing. Okay. That's true. Let's do question 23. A ball is released from a rest about a horizontal surface. It bounces once and it is caught. Which graph represent the variation with time t of the velocity v of the ball? Okay. So from rest, it is released from rest. So initially its velocity will increase. And then after first bounce, it is caught somewhere here, let's say. So the direction of velocity should change. And the velocity, the sign of velocity should change. Okay. Over here in A, the velocity is throughout the positive. In B, velocity is also throughout positive. In C, velocity changes from positive to negative. Okay. And so initial velocity should be 0. But in C, initial velocity is not 0. It is, although it is changing its direction, but initial velocity should be 0 and the velocity should increase. Over here, it hits the surface and after hitting, it moves in the upward direction and it is caught somewhere here. That's why these, after first bounce, it is not reaching to the same initial position. That's why the area of this part is not equal to that part. So D is the right answer. Okay, so if we are going to find the, if examiner asks you to tell the speed time graph of that motion, so speed will remain always positive, then your answer would be this. At this position, it hits the surface, then after first bounce, its speed is little bit decrease, and then speed decreases to 0. This is speed time graph. Examiner can ask anything, so be careful. Okay. So this graph will be when the object is thrown in the upward direction, then initial velocity will be maximum. It reaches to, no, it will be speed time graph. And this graph will be when the object is thrown in the upward direction, it moves in the upward direction, velocity decreases. Then at this point, it is at top position, then it comes down. So, okay, so over here is D is the right choice. Question 24. A ball is released from rest above a hard horizontal surface. The graph shows how the velocity of the bouncing ball varies with time t. At which point on the graph does the ball reaches its maximum height after the first bounce? At maximum height, velocity will be 0. After first bounce, when it will reach at maximum height, over here velocity will be 0. So A, C, over at A velocity is 0 and at C is velocity 0. But at A, the object has the maximum. At A, the object is in contact with the surface. The velocity over here increases, object is going down, down, down. At this point, it hits the surface. Then its velocity changes from a positive value to negative value. Because when it is moving in the upward direction, starts moving in the upward direction, the sign of velocity will become negative and its velocity decreases and it becomes 0. So the object is at the top position at point C. So after first bounce, okay? After first bounce. If it is after second bounce, then your answer would be this time, okay? During this part, object is moving down after first bounce, after moving down. Again, straightforward question. We have done that. The velocity of the car changes. What's the acceleration of the car? Again, rise over run. But be careful to convert this kilometer per hour to meter per second. Question 26. A velocity time graph below is for stone thrown vertically upward. So initial velocity is maximum value, then velocity decreases. At this point, it reaches at the top position. Air resistance is negligible. The stone is thrown up with at time t equal to 0. Area x represents a distance 5 meter and area y represents a distance 3 meter. So, as it is thrown upward, it moves a distance of x. For example, it is 5 meter over here, it is straight. Then it comes down and during return journey, the area of y is 3 meter. So what is the displacement of the stone from its initial position? Very simple, straightforward question. That will be the displacement, the shortest distance from this point. So 5 minus 3, that is 2 meter. A mass m on the end of the spring bounces up and down as shown after being released at time t equal to 0. Which graph shows how the velocity varies? Okay. So area of the displacement time graph will give us velocity at t equal to 0. Its gradient is 0 over here. So velocity should be 0 at that point and velocity should be 0 at the second point and so on. So at t equal to 0, velocity should be 0. And you can see in A, in B, the velocity is not 0. It has some value. And in other three options, velocity is 0. So velocity should be 0 at this second point, okay? So that is true over here, 0. And that's why in C, you can say velocity also 0 at the second point, but the velocity is not 0 between these 2 points. The gradient is not 0 during this interval. Okay. So that's why the gradient has some 0 value, then gradient increases, it becomes maximum, then it decreases, So initially gradient is 0 and gradient increases to maximum value, like you can see over here. Maximum value at this point, then it decreases to 0. After that, from this point, the gradient becomes negative and it increases. So that's why the velocity is negative, increases, and it becomes 0 after at this point. So that's why A is the correct option. Why not D? In D, you can see the velocity is 0 at this point, velocity is 0 at that point, and 0 at that point. But over here, the gradient of this velocity time graph is increasing, then decreasing, that become 0. So at this point, the gradient should be 0 and the displacement should be the distance should be 0 at that point. Okay. No, 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 no. There is something wrong. Okay. So the gradient of distance time graph is velocity, and over here the gradient has some non-zero value. So velocity should not be 0 at that point. Okay. That's great. That's great. In this option D, the velocity is throughout positive. That shows the gradient of this graph should not change the sign. But in this option, after this point, the gradient is changing its sign. You can see from here. The gradient at this point is, gradient over here is 0. And after this time, the gradient becomes negative. So that's why A is the correct option. 28. Which feature of the graph allows acceleration to be determined? Very straightforward question. Acceleration is area under displacement time graph is nothing. Area under velocity time graph is displacement. Slope of displacement time graph is velocity. Slope of velocity time graph is acceleration. And we wanted to find acceleration. So which feature of the graph allows acceleration to be determined? So acceleration is the slope of velocity time graph. Very straightforward question. Velocity time graph, we are given velocity time graph, and wait a second. The graph shows how the velocity of an object moving in a straight line varies over time t equal to 0 to t equal to t. Which graph represents the displacement s of the object? So we are given velocity time graph. Velocity is 0, velocity increases. So the gradient of displacement time graph should be 0 at the start. You can see gradient over here is 0. Over here in that option B, the gradient at the start is non-zero, non-zero, and gradient is 0. So that's why I ignore these two options. Then the gradient should increase as the velocity is increasing. As the velocity is increasing, the gradient of displacement time graph should increase. Should increase. So over here, the gradient increases, it becomes maximum. Then gradient decreases to 0. So gradient decreases, it becomes 0. Okay. So gradient is 0 somewhere between 0 and t. Then velocity becomes negative. This means the gradient of displacement time graph should become negative, and it is becoming negative in option A. And velocity is increasing, the magnitude of velocity is increasing, so the gradient is increasing maximum, and then it becomes 0. So that's why option A is correct. Okay, that's true. A brick is dislodged from a building and it falls vertically under gravity. Which graph best represents the variation of height h above the ground with time t if air resistance is negligible? If air resistance is negligible, then the acceleration should be constant. Then if acceleration is constant, velocity time graph should be a straight line, and velocity of the object should increase. In height, the gradient of height time graph will give us velocity. The velocity is increasing. Over here, velocity is constant. Velocity can't be constant. Okay. In h, the gradient is constant. In c, sorry. In d, what is happening to the velocity? Velocity is increasing. So in both A and C, D, the velocity is increasing. But how to pick out of these two options? What is your right choice? Initially, the height should be maximum. It is dropped from some height. So height can't be 0. That's why we will pick this option. A is the correct choice. Over here, the variation with time t of the distance s moved by a body is shown below. What can be deduced from the graph about the motion of body? The gradient of this part is constant, then gradient have greater value, but it is constant. It accelerates continuously. The distance time graph gives us velocity and velocity till the first part. Over here, v is constant and v is also constant, but has a greater value over here. Acceleration is, so it is not continuously accelerating. It starts from rest, okay? No, it's not starting from rest because the gradient of this part at time t equal to 0 is not 0. The distance is proportional to time. The speed changes, okay? The speed changes. That's good. Speed over here is some constant value, then speed changes to another constant value. Distance is proportional to time. Distance s is not proportional to time. The proportionality should be, this is for whole journey. If distance time graph look like this, then distance is proportional to time. But over here, distance is not proportional to time. So that's why D is our right choice. A ball is dropped from rest and falls towards the ground. Air resistance is negligible. Which graph shows the variation with speed of the height of the ball above this? A ball is dropped from rest. So initially its velocity should be 0 and falls towards air. Air resistance is negligible. Okay. So that shows the velocity height time graph should not be a straight line. This question is similar to that question. Question number 30, exactly. Okay. So height, initial height should be maximum, and in A, velocity is constant. So that's why it is not the right choice. In B, velocity is also constant. In C and D, velocity is changing, but in C, the initial height at t equal to 0, the height is maximum. Over here, the height is 0. So at t equal to 0, it has the maximum height. So height should decrease. That's why C is correct option. Okay. A particle moves in the manner shown by the velocity time graph. The displacement of the particle has been measured so that it is 0 at t equal to 0. Okay. Point Q refers to a point in its motion. Which row of the table is correct? Okay. So acceleration 8. Over here we have velocity time graph, and point Q refers to a point in its motion. So initial velocity is 0. You can see the velocity increases to maximum value, 2 meters per second, then velocity decreases, then velocity becomes negative, and so on. So that is a graph of an oscillating body. Times for maximum displacement. Times for maximum displacement. Okay. At t equal to 0, displacement is 0. Object velocity is positive, 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 positive. This means the object is moving in the same direction. Okay. The object is moving in the same direction. So it started from somewhere here, t equal to 0, and its velocity is maximum somewhere here at 5 seconds. it is away from this point. Then velocity becomes negative. It is moving towards the same point. So we have to find uh, acceleration at q is very straightforward. It is 0. So acceleration at q can't be 2. It is 0. So these two can be correct. But time for maximum displacement, how to pick that? You should also think. Okay. So maximum displacement is, you can see the velocity is increasing. It is moving in the same direction, is moving away from that point. So at 5 seconds, its displacement is maximum. Then it moves towards the same point. Okay. So at 5 seconds, it has the maximum displacement. Then it is at the same point at 10 seconds. Okay, at 10 seconds, it is at the same point. Then it moves in the opposite direction, and it has maximum displacement at 15. So that's why D is correct option. A tennis ball falls freely in air from the top of tall building. Which graph best represents the variation of distance S fallen? If it is a tennis ball, then air resistance will affect its motion. We cannot ignore air resistance. So this means acceleration will not be constant, and eventually it will reach to the terminal velocity, and the gradient of displacement time graph should become constant. So initially the gradient should be 0. Over here the gradient is non-zero. Over here it is 0. Over here it is non-zero. Okay. So that's why I just ignore these. Over here we can say it is 0, but the gradient is continuously increasing. So velocity is continuously increasing. It is not reaching to the terminal velocity. The gradient should become constant. And in option A, the gradient increases till this point, and after that it becomes constant. So velocity is constant. So that's why option A is correct. Question 35. The diagram shows a velocity time graph for a vehicle, meter per second. The vehicle moving at 4 meter per second begins to accelerate at time t equal to 0. What is the vehicle acceleration at time t equal to 3 seconds? So we have to draw a tangent over here, and we have to calculate the gradient of this tangent. That will give us the vehicle acceleration at t equal to 3. So you have to calculate gradient of this part. It's up to you, whether you take smaller triangle or larger triangle. But that will give you an approximate answer. So find the area, sorry, not area, gradient of this triangle. Okay, so you will get the right answer. On vertical axis, you have, this is from 3, so 3 till, no, not 3, it is 6, 6 till 12, so it is 6. On horizontal axis, 3 till, so 4, 3 till 7. So 6 over 4 is 1.5. So 1.5, the closest value to 1.5 is 1.3. Closest value to 1.5. You can calculate. I was, my tangent may be little wrong because it is not touching it. I have to draw it with sharp pencil at equal to 3. So that will look like this. And if you will calculate the gradient of this, you will notice it is 6 to 10, that is 4. And over here it is 3. 4 by 3. It's around 1 point something. Okay. 1 point, I think 1 something. So it is closer to 1. So that's why B is correct answer. So be careful about these type of calculations. Again, height time graph, the the small steel ball, no air resistance. Which graph best represent the variation of the height? So acceleration is constant. That shows the velocity should increase at constant rate. The velocity should not be constant. The velocity should increase and it should not reach to the terminal velocity. So initially the height should be some maximum value. So that's why D is not. So B is the correct answer. The gradient should increase continuously. It should not decrease. The diagram shows a velocity time graph. What is the displacement during last 2 seconds of the motion? Last 2 seconds. So you have to find this is last 1 second, last second. So last 2 seconds, you have to find the area of this part. Very straightforward, you can do that. So area is the sum of parallel side, that is 12, this is 6, and that is 4. So 1 by 2, 2 height into sum of parallel side becomes 18. So that is 18 meter. So now I think I should end this lecture. We have many more questions to do, but I hope I have done enough for you, and the rest of the question you should do by yourself. I will share this document over there. So thank you so much.